Hey everyone, Mr. Fransky here, coming at you with some BC Calculus notes. Today we're going to be going over the 2.4 worksheet. Just got some notes on here, just kind of recapping everything that we learned, just because it was a little bit tricky to do some of this tangent line stuff. So we're looking at secant, tangent, and normal lines. Students will be able to construct a tangent and normal line from its secant analytically and graphically. So remember that picture we had where we had the secant line. Then we said we're going to make it closer and closer by taking that limit statement of Fermat's difference quotient. So that's kind of what we're focusing on. So limit. Limit we've been talking lots about. As x approaches a certain value, what's happening to the y's. Rate of change, remember f of b minus f of a over b minus a. Secant line is the one that goes through 2 points of a function. A tangent line is the one that just bounces off the function. And a normal line, remember, is one that is perpendicular to the tangent line. So let's take a look. A couple definitions. So average rate of change. So this is the change in a function. Change in a function. Over an interval length. So that is f of b minus f of a over b minus a. An example here, find the average rate of change of this function over the interval 4, 9. We did this problem in class, but let's take a look at it again. It's not too bad. So we're going to do f of 9 minus f of 4 over 9 minus 4. That is 1/3 minus 1/2 divided by 5. This is 3/6. This is 4. This is 2/6. This is 3/6. So we have negative 1/6 divided by 5, which is negative 1 over 30. Now they ask us for the equation of the secant line. So this 1 over root x is something like this. So 4 might be here, 9 might be here. We're looking for the equation of that line with negative slope. We can use either point. I might use the 4 1/2 this time. Why not? Y minus 1/2 equal to our slope, which is negative 1/30 times x minus 4. That's all there is to it. All right, let's look at a tangent line. So instantaneous rate of change. So this is how the function is changing at a given instant. So how the function is changing at one point. So sometimes you hear this called the slope of the function, because what's going on is we're saying, well, how many units are you changing right there? We're not using 2 points, we're just using 1. So the formula for this is just going to be the limit of our difference quotient. So the limit is h approaches 0, f of a plus h minus f of a divided by h. And if we plug in 0, we get 0 over 0 every time, because you're finding the slope of 1 point. But we have some ways to algebraically work around that. So let's take a look. Find the equation of the tangent line at y equals x minus 1 squared plus 1 at x equals 3. So we're going to do limit as h approaches 0. F of 3 plus h minus f of 3 divided by h. So that is limit as h approaches 0. Let's plug these into our function. So it's going to be 3 plus h squared plus 1. Minus f of 3, which is 3. Oh, I missed a piece in there. Let's try that again. So f of 3 plus h. 3 plus h replaces the x. So we have 3 plus h. I knew I had something wrong. Minus 1 squared plus 1. There we go. So that's the first part. And then we subtract off f of 3, which is 3 minus 1 squared plus 1. Subtract off that whole thing divided by h. All right. So now we're going to expand a little bit. So 3 plus h minus 1. Well, I'm going to combine the 3 and the 1 here. So that's 2 plus h squared. So we have 2 plus h squared plus 1. Minus, this will just be 2 squared plus 1 divided by h. So that's the limit as h approaches 0. This is 4 plus 4h plus h squared plus 1. And then 2 squared is 4 plus 1 is 5. So we minus 5 there, all over h. 4 plus 1 is 5, so those cancel out. Now we can pull out an h. So we have h times 4 plus h divided by h. The h's cancel. This is limit as h approaches 0. Oops. And so now we can plug in 0. This equals 4. Okay, so we have our slope. Nice. So slope, we've got, let's see if we can get a point. So we're going to be 3, comma, 3 minus 1 is 2 squared is 4 plus 1 is 5. So y minus 5 equals 4 times x minus 3. Not bad. Cool. So normal line. Normal line, remember, means perpendicular to the tangent. So first thing we have to do is find the equation of the tangent line here. So we're going to do limit as h approaches 0. F of a plus h minus f of a over h. So plug in 2. So we have 1 over 2 plus h squared. Limit as h approaches 0. 1 over quantity 2 plus h squared. Minus f of a, which is 1/4, divided by h. So we got to expand the bottom there. We got limit as h approaches 0. Let's see here. We got 1 over 4 plus 4h plus h squared minus 1/4, all divided by h. Oh, fun. We get to find a common denominator. So here we get 4 plus 4h plus h squared on top and bottom. Here we get 4 and 4. So let's see what we have now. So on the top here, we have limit as h approaches 0. On the top, we have 4 minus 4 minus 4h minus h squared. Minus on all those because this negative distributes. And then, let's see here, 4 minus 4h minus h squared. Yep. And on the bottom, we have 4 times 4 plus 4h plus h squared. So the 4's cancel up here. We can take out an h, and let's see what we have. So looks like we have, oh, that's all divided by h. I was going to say, we're missing something. So let's time 1 over h. That's this h right here. So that is limit as h approaches 0. So we can take out an h. So we have h, I'm going to take out a negative h actually, times 4 plus h, divided by, we can distribute this in here, 16 plus 16h plus 4h squared, multiplied by 1 over h. The h's cancel here. And let's see what we've got. So now we can plug in 0. We get negative 4 upstairs. On the bottom, we get 16. Negative 4/16 is negative 1/4. So that is the slope of the tangent line. We're asked for the equation of the normal line. So the normal line is going to have a slope. Opposite reciprocal is positive 4. And our point, well, we've got the x, it's 2. And the y we get when we plug it in, so it's 2/4. Sorry, 1/4. Come on. All right, so we got y minus 1/4 equals 4 times x minus 2. That's all there is to it. So a few definitions just to make sure we get these in place. A secant line goes through 2 points of a function. So if we draw a graph of that, any 2 points, so something like that. That's a secant line. Tangent line just touches at 1 point, and it just, I'm going to write it, brushes by the function. All right, and then the normal line is perpendicular to the tangent line. There it is. So if you want to find the normal line, you got to find the slope of the tangent, and then you're going to take the opposite reciprocal, and that's going to give you the slope for the normal. Same point, though. I think that's it. So quick warning to some of you, especially those in physics, may already know how to do derivative shortcuts. You might be jumping ahead to some of those formulas you've been using for derivatives in your science classes. But it's really important in calculus that we learn how to do this with limits. So make sure when you're doing this in calculus for chapter 2 at least, that you're doing this in terms of limits. If this doesn't mean anything to you, then don't worry about it. But just make sure that you're doing this the algebraic way that we've been taught. That's it for me. Love you guys. Have a great day.